Hi friends, today we are going to discuss about limitations of p-value. Before talking about limitations of p-value, we need to know what p-value is. Have you ever thought about p-value? To understand p-value, let's get familiar with some statistical term and definitions. Hypothesis means a testable proposition or supposition, but for our purpose, we will be concerned with hypothesis about probability distribution or the parameters involved in it, called statistical hypothesis. For example, the agronomist may have to decide whether or not the new strain of wheat developed by him will significantly improve the yield. The industrial engineer may have to determine whether or not the new production process will significantly reduce the cost. The sales manager of a soft drink manufacturing company may have to choose between newspapers and television for launching his advertisement campaign. The person who is taking such a decision in agriculture, industrial economics field always face the risk of making a wrong choice. Statistical techniques can be used to evaluate or quantify such risk and if possible to provide criteria for minimizing the chance of making wrong decision. Such technique fall into an area of statistical inference called testing of hypothesis. Test of hypothesis. Rules or procedures which enable us to decide whether to accept or reject the hypothesis or to determine whether observed samples differ significantly from expected result are called test of hypothesis or test of significance. Then about null hypothesis. The hypothesis to be tested is usually referred to as null hypothesis and it is denoted by the symbol H0. The null hypothesis is a proposition of zero differences. Fisher has emphasized that every experiment may be said to exist only in order to give the fact a chance of disproving the null hypothesis. Thus, a hypothesis which is set up with the possibility of its being rejected at some defined probability value is called the null hypothesis. For instance, if we want to show that students of college A have higher average IQ than the students of college B, then we might formulate the hypothesis that there is no difference between college A and college B. Next, about level of significance. The validity of H0 against that of H1 can be tested at a certain level of significance. The level of significance is defined as the probability of rejecting the null hypothesis H0 when it is true or the probability of type 1 error. Actually, this is the probability of the test statistic falling in the critical region when the null hypothesis is true. So, significance level is also called size of the critical region, size of the test, or producer's risk. It is denoted by alpha. Alpha is usually expressed as the percentage, such as 1%, 2%, 5%, and 10%. Then about our p-value. P-value means the probability for a given statistical model that when the null hypothesis is true, statistical summary would be equal to or more extreme than the actual observed results. Then about the steps in p-value approach. First one, the state the hypothesis, set the criteria for a decision, identify the correct test statistic, calculate the test statistic using the relevant properties of your sample, specify the characteristic of test statistic sampling distribution, place your test statistic in the sampling distribution to find the p-value, make a decision. However, there are some drawbacks and misuse of p-value. In the past 2 decades, this misuse has become increasingly common and problematic as rapid advance in technologies have enabled collection of high dimensional features in cancer research. In recent years, There have been vigorous debate about p-value, including its limitations and flaws. The American Statistical Association (ASA) has put out statement on p-value with warnings against its misuse and suggestions on alternatives and complements to p-value. The best way I can frame the problem of p-value is that p-value gives the probability of observing the data given the null hypothesis is true. But after an experiment is done, what we are really interested in it, the probability of whether the hypothesis is true given the data were observed. These two probabilities are quite different, sort of like comparing the probability that a man is a president versus the probability that the president is a man. Many factors may impact the evidence for rejecting a null hypothesis, including but not limited to study design, sampling scheme, data collection process, and analytical models. It is particularly noted that p-value is a function of sample size with a large n leading to a small p-value. For instance, National Cancer Registry data or electronic health records have been widely used for cancer research for, say, uncovering patients' heterogeneity and thus identifying potential risk factors with the ultimate goal of improving cancer outcome. In such analysis, p-value could be very small. However, if the effect size is close to null hypothesis, then the finding may not be clinically meaningful. Such findings are also less likely to be reproducible due to potential biased estimation. As the sample size increases, model misspecification and estimation biases more concern. Or in other words, if the effect size estimate is biased, then its associated p-value is not meaningful. One disadvantage of p-value is that they do not account for multiple comparison or the impact of other factors on the result, as well as bias in the data interpretation. Another disadvantage is that p-value do not provide an estimate of the size of the effect. This means they don't show the strength or magnitude of the relationship between two variables. This can make determining the clinical relevance of the result difficult and lead to overgeneralization of the findings. The next one, it is important to note that p-value is calculated given the null hypothesis is true and does not rely on the alternative hypothesis. Thus, p-value can be used to reject or fail to reject the null hypothesis but cannot be used to accept the null hypothesis. In addition, large changes in the underlying quantities, such as treatment effect estimates, suggesting a clear distinction between scientific significance and statistical significance. Another common misuse of p-value is inflated type 1 error due to multiple comparisons or tests. As the number of simultaneous tests increases, it is well known that the probability of getting at least one statistically significant result due to random chance would also increase, this leading to a higher level of false positive. Sometimes this misuse can be subtle and not obvious. For example, many basic science cancer studies include multiple experiments for which statistical analyses are conducted for each experiment with the same threshold level for p-values separately. P-values are typically computed for a specific model or statistical testing procedure based on its theoretical properties. Thus, if the model or testing procedure used is misspecified or the assumptions underlying the methods are violated for the data being analyzed, the resulting p-values would not be valid and would lead to the flawed conclusions. Hope you understood the basic concepts of p-value and its limitation. Thank you.